Good day, user. We are from group 7 and our mechanism is a flushing system. So we will begin with a modularization with the FPD and explanation, followed by the calculation by myself, Sharan Kumar. Sukri will explain about the analysis. We'll start off with the first presenter.
Okay, hi, my name is Mugilarsan Subramaniam. So I like to present about introduction of our project. So the first process is when you press the handle, a lever inside the tank pulls the piston up, then forcing some water through the siphon. Siphon means the U pipe in our 2D diagram, the big pipe one. That's the name of siphon. Then this provides suction in the siphon and the rest of the water within the siphon U-tip flows. Then the piston usually covered by the plastic membrane which is constructed by the suck out of the way by the emptying siphon tube water. Then they allowing the rest of the water in the tank to rush past the piston and over the top of the siphon, emptying the rest of the tank. After that, the piston membrane then drops back onto the piston ready for the next flush operation. After that, the tank empties quite quickly and the float ball floats to the bottom. That means the float rod is no longer pressing against the valve, so water begins to flow into the tank, filling it up again. Then lastly, the water which left the tank goes through a short pipe to the toilet bowl. It salts around the rim, down the side of the bowl and out through the drain pipe. Okay, then usually the full flush works just like another toilet using roughly 1.6 gallons of water to remove the mixture of solid and liquid waste. The partial flush, on the other hand, is designed for only liquid waste and use 1.1 gallons of water. So here you can see our free body diagram of our flush mechanism. So first picture is AB. There are four force. First is 50 Newton. The the length of lever is 1.5 meter with 30 degree angle. So next is force D. It's F2 force is dy and dx F5 meter and at 45 degree. The last is BC. There are four force By, Bx, Cy, Cx, Cyx the piston and the length is 1.5 meter. So that's all for me. The calculation will explain by my friend.
Okay, thank you, Mugilarsan. So the next you will see calculation that is involved in the FPD. So as you can see, first you're going to find the moment from member of AB. So the components that we are going to use are By times will be 1.5 meter sine 30 and added with Bx 1.5 meter cos 30. That will be our first equation, followed by the Fx. We are going to be taking x minus Ax and follow the third one which is Fy negative dy minus. So we are going to use these three equations at first. Find the moment, followed by the second one, which is member of BC. In member of BC, we're going to find MC first. With Bx Bx times with 3.5 plus with 50 and times with 1.5 cos 30 will be our next formula, followed by Fx, which is equal to Bx plus Cx equals 0. And for Fy, we're going to take negative By plus Cy equals 0. So we're going to be we're going to be taking this equations first. Then we will solve one by one to get the moment. So from equation 3, we can obtain the value of dy, which is negative 50. So we can solve bx from that. Is bx times 3.5 meter plus with 50 times 1.5 cos 30. So from that we can get a bx value of 18.55 Newton. Since we get the bx value, we can use it to solve the cx, which is 18.55 cos 30 plus cx. We get the cx value of 16.06. Next, we're gonna sub the cx to get the value of cy. Negative 50 sine 30 plus with cy, get the value of cy. Third one is a ball. Find fx through 5 cos 45 minus dx. So now we're going to find dx here. Through the calculation, we can get dx equal to 2.62. Fy, we can say that negative 5 sine 45 plus with dy, we can get the dy value of 4.25. From that moment at A, we can conclude that the value of a dy can be 1.802 Newton. So this is the calculation part. Next, we'll look into the analysis from Dupree. Okay, should we talk about the analysis?
Okay, hold on a second. Okay, for force of analysis, first we have two FPD. So by inspection, member AB is a two-force member, and the free body diagrams of the three bar are shown in figure next to the article. And since pin at B connect only two parts together, which is C and A, the forces there are shown as equal but opposite on the separate free body diagrams of their connected members. In particular, four components of force X on the piston or plunger, which is By, Bx, Cy, and Cx. The directional sense of each of the unknown force is assured, and the correct sense will be established after equation of equilibrium are applied. So on the torsional force, so as we know, a torsion force is a load that is applied to a material through torque, and the torque that is applied creates a shear stress. So if a torsion force is large enough, it can cause a material to undergo a twisting motion during elastic and plastic deformation. So as we know in this assignment, the torsion force happens at the plunger through the string connecting the parts, and the torsional force equation is shown on the slide, which is T equal to P over J, and we find the diameter, which is 4.25 over 2.73 equal to 1.69 Newton. Next, we predict safety factor, which is the formula strength over strain, and the value of strength is 56.82. We divide with the value of strain, which is 0.43, and the final value for the safety factor is 132.14 Newton. Okay, that's all from me. Thank you.
Okay, so that is all from group 7. Thank you for your time.